All right, this is the last part of the connective tissues notes. This is part 3, and I'm going to go over the specialized connective tissue types of fluid connective tissues and supportive connective tissues. So, the functions and anatomies of the ones we're going to go over are the fluid connective tissues, like I mentioned before, and supportive connective tissues, which primarily break down into the cartilage tissues as well as the bone tissues. And finally, at the end, I'll go over some pictures of all those tissues as they are found in a typical slide. So, fluid connective tissues are fluid. And the reason why they're fluid is mainly due to their matrix. So, the ground substances that are generally either gel like or firm, in this instance, contain only dissolved proteins and little to no insoluble fibers, which allows the consistency of the tissue to be fluid as a result, because there's nothing kind of holding the cells locked in place because the matrix is so soluble, basically. Generally speaking, you're going to see fluid connective tissues found in either blood, so blood is a fluid connective tissue, and lymph. Okay? So their matrix is the thick fluid that surrounds the cells. So blood has cells in it, but it's also a little bit sticky because the fluid around it is viscous. Viscous meaning a little bit thick, and that thickness is dissolved stuff. That's the dissolved stuff in this instance is actually the matrix of blood. Okay? So, when we talk about fluid connective tissues, the 3 main types of cell types we talk about are red blood cells, white blood cells, and platelets. So, red blood cells, also known as erythrocytes, look like this. They look like kind of donuts that are kind of like, not donuts, discs that have been pushed and dented in, or like frisbees that have been bent. Okay? And this red blood cells compose almost half the volume of blood that is found there, and they are made of cells, and their whole job is to transport the oxygen around the body. And in this instance, their red color, the hemoglobin protein inside of them that help them move oxygen around, is what gives blood its red color. The fluid matrix around them is actually clear. White blood cells aren't as abundant as the red blood cells. They actually only make a few percent of the cells found in blood. But in this case here, they play a really important role in fighting off infection in your immune system, and they play a huge role in your immune system, and they kind of move throughout the blood and other fluid tissues like lymph, and they can even flow inside of your loose connective tissues to help seek out and look for viruses and bacteria that can cause harm to your body. Generally speaking, these cells, when stained, they're big and round and circular, and oftentimes they have like a really dark and sometimes horseshoe or weird shaped nuclei in the center. And that nuclei helps play a big role in its ability to look for and destroy dangerous organisms. Platelets, on the other hand, are tiny cell chunks that actually are useful, and they're found in your blood. And what they do is they kind of move around, and they got little spiky corners on them. And if you get a cut or anything like that, platelets are capable of plugging up that cut and preventing you from bleeding out. Now, fluid matrix depends on what it's made of. The most common fluid matrix that we discuss when we talk about fluid connective tissues is plasma. That's the fluid that surrounds the cells in your blood. Lymph is a different system. Lymph is a fluid that flows through what's called your lymphatic vessels. Your lymphatic system is kind of a weird system that flows side by side with your blood flow, except moves a lot slower, which gives more time for your white blood cells to travel around your body and look for viruses and other things. So, your lymph fluid is sort of like a parallel to your blood vessels. Think of your blood vessels as a high-speed freeway for moving stuff around your body, and your lymph vessels as like a slower side street that's moving stuff around your body. But in this case, it also has its own unique type of fluid and cells that are very similar to blood, but in this case, less red blood cells, a lot more white blood cells. But it's still kind of it's still liquid tissue flowing around your body. And finally, we have interstitial fluid. Interstitial fluid is fluid that's surrounding your cells, like all your organs are a little bit liquidy, and they eventually will diffuse and flow into either the lymph liquid or the blood liquid. They'll kind of pass and exchange fluid with them and go back and forth. All right? But ultimately, in blood and lymph, that's the source of their liquid that's surrounding their cells, the liquid matrix that's surrounding their cells. Most of the fluid that's not inside the cell can be found in your fluid connective tissue, especially blood. But again, the thing that's allowing them to be liquid is the fact that they have a lot less fibers than other connective tissues. So these are a scanning electron microscope picture of white blood cells, red blood cells, and platelets, for those of you wondering. So, in terms of a high school lab, generally speaking, you're not going to have images of other fluid tissue types other than blood. But the blood fluid tissue type is very distinct. So, this is the red blood cells, and then randomly, you're going to see white blood cells pop up. Those little specks that you see here and here, that's actually platelets. Platelets that you're seeing all around. That's a platelet too. Okay? So, that's what blood tissue looks like under a real microscope. All right, let's go over the last category of connective tissues called supporting connective tissue types. So these things help provide the scaffolding that forms your skeleton, that holds your organs in place and creates cages for your organs to hang off of or be protected by. And there's two main types of connective tissue, supporting connective tissue. It's cartilage and bone. So these connective tissue types provide a really strong and rigid framework that helps support your rest of your body. And the main thing here is they have lots and lots of fibers and deposition of lots of minerals, particularly insoluble calcium salts. They're going to help create that rigidity in your skeletal frame that helps you stay upright.
So the supporting connective tissues are the tissues that basically form your skeleton. So there's two major types of categories of tissue in your skeleton: bones and cartilage. So cartilage, I like to think of as sort of the rubbery parts of your skeleton, the parts that give it like cushioning and bendability, like flexibility. So in this case, cartilage, you want to think of it as sort of the firm, rubbery like gel that sometimes holds extra fiber in it to give it special functions. Unlike bones, though, and unlike a lot of your other connective tissues, it doesn't have any blood supply. It's truly avascular. It has even less blood supply than your tendons and ligaments, which means it has a really hard time repairing itself because there's no actual blood vessels in the cartilage and entirely relies on diffusion of the materials it needs for repair from areas far away from the cartilage, from the outside of the cartilage. As a result, the cells inside the cartilage, the chondrocytes, they tend to sit inside the cartilage rubber. They sit in little pockets called lacunae. And again, they're going to have to wait for diffusion of materials from the outside of the cartilage. So here's an example of, you might have a really thick pocket of cartilage at the end of your knees. Not you might, you do. One of the most common areas of this cartilage is called the meniscus. So in this case, the cells sit inside that rubbery cartilage, and it's trying to build itself and it's trying to build more cartilage, but that blood flow is entirely coming in from outside the actual rubber. So if you tear this, it might take months, it might take years to even heal decently. And even then, sometimes you won't ever get it to fully heal, and the best thing you can do is to just shave off the damaged part, which is something you might hear about a lot in in sports, like where people like have no knees, quote, because their meniscus keeps getting busted and they keep having to get knee surgery to just shave down the meniscus so it's still playable. So there's actually three categories of cartilage types. So the base model of what I like to think of it as, the most basic form of cartilage is hyaline cartilage. The next form of cartilage is fibrocartilage, cartilage, and the last form is elastic cartilage. Within these tissues, I like to think of the chondrocyte cells themselves. They're a very small portion of that tissue, but they're there to kind of form the material around those cells. So, and I like to think of them as sort of looking like eyeballs. I'll show you what that looks like in a moment. And the fibers that happen to be in some of these types of cartilage are just the same as all other connective tissues. In this case, for fibrocartilage, it's collagen. In the case for elastic cartilage, it's elastin, and it's going to allow it to have its sort of special properties of extra strength or reinforcement. So these are sort of what I like to draw them out as in terms of the cartoon, and here's what they look like in real life. I'll talk about these images more in just a little bit. So in terms of hyaline cartilage, again, this is the baseline model. I like to think of them as always almost having like a bug eye or alien eye looking appearance, because they tend to have like a lot of eyeballs kind of jammed together, like 2 or 3 or even 4 lacunae hooked together. They don't have any fibers. They just have their glossy, rubbery matrix built around them. And it's the most common form of cartilage. You're going to find it building the outside of your nose. It's going to be found at the end of bones. If you've ever eaten a chicken bone, that is the white rubbery cartilage at its ends. That's hyaline cartilage. And you find also a lot of it in the rib cage. Now, the other cartilage types are very particular, and they're only in a few locations in the body. So fibrocartilage is a cartilage you're going to use if you need a lot of extra strength in that rubber for putting a lot of weight in that area of your body. So you're going to find a lot of it in your vertebrae, aka your spine, in between the spine bones or vertebrae bones. You're also going to find a large bit of fibrocartilage at the bottom of all your knees. And again, that's called the meniscus. And so it's a huge pad of extra cartilage only found in your knee and nowhere else in your body. And that's, again, to allow you to have that extra weight bearing when you're jumping, running, etc. Elastic cartilage is only found in areas of your body where you want a little bit of structure, but you want that structure to be very bendy, aka really flexible. And so that elastic fibers within the cartilage tissue itself is going to allow it to be really stretchy, but also allow it to bounce back to where it was. So you're going to find this elastic cartilage with a lot of elastin in it in your ear flaps. When I say ear flaps, meaning your outer ear, the soft parts that we pierce. You're also going to find it in the middle of your nose, aka your nasal septum. So the middle part, if you ever touch it, it's a space between your 2 nostrils. It's quite a bit softer than the outside of your nose, for example. So this is the softest, bendiest cartilage in your body. In terms of the shape you might see in the microscope, again, hyaline cartilage tends to look really glossy, sometimes really shiny and like neonish or white. And then the lacunae look almost like, again, little bug eyes are like side by side. The fibrocartilage eyeballs tend to be more spaced out. I think that's possibly because they need more space to produce the collagen that's woven in a parallel direction. It's a little ripply, but it is moving parallel to each other across the tissues. And I like to think of the eyeballs as looking kind of like it's giving you the side eye. And then elastic cartilage, they're giving you like anime eyes. They're massive eyeballs for its chondrocyte cells. And in addition to that, the elastic cartilage is kind of looks like sort of spider webs running in all kinds of direction, which gives it that soft bendiness that we desire wherever the elastic cartilage is found.
So bone connective tissue, also known as osseous, is a tissue, connective tissue that, but in this case, its matrix has hard calcium compounds that create this rigid, tough structure. But it still has a little bit of flexibility in it due to the collagen fibers. That's why our bones don't crack when we jump up and down. But if you know, a dead skeleton is actually really fragile because all the cells that make the fibers have long died, so it no longer has the fibers to keep it flexible and together, and rather it's just calcium at that point, chalk, and it can crush really easily. But that addition of collagen is what allows it to be strong and resist shattering. That mix of collagen with the calcium chalk type substance. All right, so the main cell that helps create those fibers as well as help maintain and the matrix and help produce the calcium and keep it in the right amounts is the osteocytes. So they're the cells that help form the bony calcium matrix and maintain them. And again, they're going to sit inside the lacunae for the exact same reason, where as it was laying out the solid matrix around that cell, it kind of locked itself in place and then it was stuck in a pocket due to the bone house that it built around itself. So the lacunae is also found in this instance. Now, the structure of bone actually ends up looking like rings. This is kind of an ugly picture, so I'm going to try drawing a slightly better picture of a bone. So, bones it's kind of a weird shape, but basically what happens is they have little pockets forming around a circle, and the inside of the bone circle actually is a tunnel that allows blood flow. So there's lots of food around it. So the cells that are growing bone really want to be as close as possible to the center of the blood flow. But they're still laying around a lot of matrix around the outside. So inside each of these pockets is our lacunae. Or is a lacunae. That it's a pocket is a lacunae. But inside each of those is a osteocyte that's laying down matrix. And that's kind of forming the outer edges. And around that is more osteocytes that are trying to grow. But there's no more space around the campfire for the blood vessels, so then they end up kind of growing on the outer edge of that. And then that's what creates those rings that you see that eventually form the bone. And then eventually, there's a limit to how large it can get. So eventually, that's the end of the bone, and there'll be a different bone clump of osteocytes next to it. Okay, so then there'll be side-by-side bone cell chunks with the osteocytes and the lacunae side-by-side in your bones. So this is a picture of bone tissue, so you can see the rings. So it grows like rings on a tree. So they get as close as they can to the blood vessel, and then when they run out of space, they grow another ring but there's a limit to how many rings they can grow. And then but each of these blood vessel tunnels provides another resource for bone cells to grow around them in circles. All right, that concludes most of the notes. Last thing I'm going to do before I go over the takeaways is just give you some more histological examples of cartilage tissues, okay? So let's go over, remember, there's 3 types of cartilage tissues: elastic fibrocartilage and hyaline. So let's just look at real examples of that so you get a good idea of what they look like, and then we'll go into the takeaways. All right, so this is another way that you can stain elastic cartilage. Kind of ugly. The staining I'm not a huge fan of, but you still see those eyeball lacunae and this kind of spider web around everything. That's how you know it's elastic cartilage. Here's another example of that elastic cartilage look. Fibrocartilage, just reminding you, it's got the ripples of dense elastic tissue with random eyeballs, or the chondrocytes and lacunae. So this is kind of a picture of that. So you see the ripples of dense fibers, but you still see random lacunae throughout. This isn't the best picture of it though, but that's sort of the idea. And finally, hyaline cartilage can look like this to an extent. It's got all those like many merged chondrocytes all together, creating that kind of multiple eyeball effect. So here's another example of hyaline cartilage and that kind of glossy, iridescent finish. All right, takeaways. Fluid connective tissues, as a recap, contains cells and is characterized because of that liquid matrix around those cells, which have much less fiber than other connective tissue types, which also, because it's fluid, allows it to transport a lot of substances inside that matrix. The solid and flexible cartilage is useful for providing soft, elastic protection and connection between body parts. And especially supportive cartilage, though, things that you need to provide extra support from force, needs extra fibers to help maintain strength so that it can hold its shape and not get damaged right away. And finally, bone, more than anything else, has a really firm matrix due to the calcium, though it still has a little bit of flexibility from the collagen, which is going to allow it to have that really firm rigidness, but not be brittle enough to break. All right, that concludes notes for the connective tissue section. Move on to any other work you have for the day. Bye.